Hi, I'm James here at the Davis Tech Welding School. Today I'd like to talk about MIG welding. The scientific term of MIG welding is GMAW, otherwise known as gas metal arc welding. Gas metal arc welding has become the world's most popular form of welding. It can be done by hand or it can be done on a robot. When it's done by hand, we call that semi-automatic. So the machine is actually doing part of the work for you, maintaining a constant voltage while consistently feeding the wire through the end of a welding gun. So the welder in this role, he's holding the gun and pulling the trigger and basically directing the wire and the arc where to send the weld puddle. The wire itself, to talk about the chemistry, the composition of the metal, it's actually roughly 97% iron, and the rest is made up of manganese, copper, a little bit of nickel, and a little bit of sulfur and phosphorus, just to name a few of the elements. Long story short, it's primarily iron. Knowing that, we know iron melts at about 2,800 degrees Fahrenheit. So what we're doing with MIG welding is we're taking that wire and we got to bring it up to about 2,800 degrees to get it to melt into the puddle. And to generate the heat to melt the wire, we're actually relying on the power source to create what we call a short circuit. So that wire is actually going to come in contact with the base metal that we're welding, and the resistance from that short circuit is what's going to generate the heat to cause that droplet to drop off the end of the wire and drop into the puddle. There's three different types of transfer that we talk about in MIG welding. The first is short circuit, the second is globular, and then the third is actually spray. Now, to be in short circuit mode, which is probably the most common weld mode when we're MIG welding, we're typically in a range of 200 to 350 inches per minute if we're talking 0.35 diameter. Now, if we want to do globular, we're actually just stepping that parameter up to anywhere from 350 to 500, and we're turning our volts up a little bit too with that. And then when we go to spray, that's kind of a different animal altogether. With spray, we're changing the gas type over to a 90-10, where with short circuit and globular, we're running either a 75-25 or 100% CO2. So that is the other essential element to doing spray welding. We need to have that 90-10 gas. So that's kind of the high-level view of GMAW and the three different modes of transfer within the world of MIG welding. In this video, I'd like to expound on those three modes of transfer, namely short circuit, globular, and spray. We talked about the different types of gases that we use in MIG welding. With short circuit and globular, we're going to use a 75% argon, 25% CO2, or you can use 100% CO2, which is a slightly more economical gas. Doesn't cost as much as 75-25. Here in the shop, we primarily use 75% argon, 25% CO2, or commonly called 75-25, and then 100% CO2 can be used occasionally as a more economical option. But the most prevalent in industry, what you're going to see is 75-25 for short circuit or globular. Now, when we go to spray transfer, it requires at least an 80% argon blend. Commonly, we see 90-10 here in the shop. That's what we use, 90% argon, 10% CO2. So that kind of gives you an idea of the different blends of gases that we use, which are required for the different modes of transfer. So gas is just one part of the equation. The other part of the equation is the volts and wire feed that we're pushing into the wire to separate that droplet from the tip of the wire. So with short circuit, we're actually going to create a very small droplet at the tip of the wire, and the current and the volts is what's going to squeeze that droplet of wire off the tip of the wire and drop it into the puddle. Now, when that droplet hits the puddle, it does splash, and every time there's a splash, you audibly hear that crackle sound. A lot of times we say bacon in the frying pan.
Holy smokes, he's cooking on garbage.
So that's actually what's creating that sound, the droplet hitting the puddle and splashing. And consequently, that's what also gives you the spatter BBs, which adhere to the sides of your weld. You know, if we go to spray, we actually produce even smaller droplets, which ease into the puddle with very minimal splash. So with spray transfer, we're not going to see those spatter BBs on the sides of the weld. It's going to clean them up. It's also going to reduce the amount of fume that's generated off the welding arc as well. Roughly 60% fume reduction when we go to a spray or a pulse spray transfer. Now, if we're doing 035 for short circuit, typically for our wire feed setting, we're going to be in the realm of 200 to 350 inches per minute for short circuit. Now, if we go 350 up as high as 500 for our wire feed speed, inches per minute, that's going to put us in a globular range. If we go over 500 inches a minute, that's going to transfer us into a spray transfer. And volts are associated with those wire feed speeds. So we may be anywhere from 19 to 21.5 volts for short circuit, 21.5 volts to 24 volts for globular, where spray, we're probably going to be 25, 26, or even 27 volts with that wire feed over 500 inches a minute. But most commonly, again, as a recap, you'll see short circuit more than any of the other transfers out there. But as we push the new technology, we're seeing more spray, more pulse. For the benefit of the safety, it's going to reduce the fume, get rid of the spatter, it's going to improve the quality of the weld. And all in all, spray and pulse are a little bit easier to run than the short circuit and globular.
I'm your huckleberry.
Now, when we're MIG welding, there's 3 different types of metal that are typically welded. And the first, most common, is carbon steel, or a low carbon steel, which is typically 25 points of carbon or lower. We're talking 0.2% of carbon, so just a dab of carbon. The second type of metal that we weld is actually stainless, which actually adds nickel and chrome with that carbon. Then the third type of metal that we weld is aluminum, and there's different series of aluminum, but just know that there's 3 types of metal: your stainless, carbon, and aluminum that are welded with MIG welding. MIG welding equipment, and really the best way to look at it, there's 2 different classes of equipment. The first class of equipment we call the all-in-one class, where the feeder, which actually holds the hub of wire and feeds it throughout the feeder and into the gun, it's all enclosed into one machine. So power source and feeder are all in one box. So for example, we have Lincoln's 210 MP or the PowerMig 360 MP. Now on these smaller machines, these are popular among home hobbyists, the do-it-yourselfers in your home garages, because typically they'll come with a 115 volt cord. Some of them are dual voltage, so you can hook them up to 230 as well. So again, if you're looking for a machine for your home garage or just around the house, then like the 210 MP or even the little 140 would probably be a good machine for you. When we step up into a bigger machine, we go to the PowerMig 260 or 360 MP, which these are going to be a dedicated 230 volt machine, single phase power. But still an all-in-one machine. On these smaller machines, they'll take up to an 8-inch hub, where these larger machines will handle the full size of spool of wire, either a 25, a 33, or a 44-pound spool of wire. And they can typically handle up to 0.45 diameter, where these smaller machines will only handle up to about an 0.35 diameter, and that's solid wire or a flux core wire. And from there, we step over into the separates class, which is more of an industrial setup, which you'll see in a lot of your general fab or industrial production shops, where the power source will actually sit separately from the wire feeder. Some shops will mount the feeder on top of the power source. Some shops will put the power source back by the wall, and the feeder will actually mount on its own little cart and scoot around the floor as you're pushing parts through the shop. And in other situations, they'll mount the feeder up on an overhead crane or an overhead boom and still follow the part and keep the power source back by the wall. But just wanted to show you the different classes of machines. Typically, the small guys are about 200 amps. The mid-size class is about 300 amps. And then your larger machines will be 400, 500, and even 600 amps for the larger diameter wires, 0.52, 16th inch, even all the way up to 564 wire in the flux core. So when we're wire feeding, we call that a constant voltage process, where no matter what you do with your torch angle or your stick out, the voltage will always remain constant. It's the current, or the CC, which is gonna cycle, go up and down based on your arc length and what you're doing with the torch. So again, these are strictly CV machines. Some of these will be multi-process, such as this PowerMig 360 MP. The MP just indicates it is a multi-process, so you can switch it over to a CC mode, which would support either stick or TIG or even a carbon arc gouge if it's a bigger machine. So that's the difference between CV and CC. We have inverters, we have transformers. Transformers are copper wound. They're typically heavier, bulkier, in the realm of 300 to 400 pounds. Whereas if we have the inverter technology, we're actually using solid state switching boards to do the switching for us on the current. And so we're able to pack that into a smaller package. This 210 MP is an inverter, for example, and it weighs in at about 40 pounds. Where in the old days, if we had a 200 amp power source, you would have been talking 300, 350 pounds. So it's a huge reduction in the weight, the footprint, just overall dimension and size of your welder. An added benefit of the inverter technology, it's going to consume less power, in the range of 25 to 30% less power than what you would see drawn from a transformer power source. I guess a third feature and benefit of an inverter power source is it has a slightly softer arc than what you'll see on a transformer power source as well. So that's kind of the broad overview of power sources and feeders and just the equipment combinations that we can put together for wire feed processes and more specifically MIG welding.